Hello everyone. In this video or this chapter, we're gonna talk about something called working um, with Windows and CLI system. This will be a short video that's explaining you how these things work. Let us go very quick. Okay. So, what the file system? File system it is this file because in computers we have two kind of file. You have or three kind of file. You have a software files. What means software files? Like I have any softwares, like a games or something, just have a file. Then we have an operating system file. Operating system file. That's files or files actually. These files are created by operating system. So it will be created and handled by the system. Also, we have a user file, our files, our file. So those we call file system. Some of those, it gives the operating system roadmap. What mean roadmap? When you turn on the computers, tell you computers up, and we see whatever in front of the screen. This is software tell the computer what they're doing. So type of the file system operating system used to determine how the data is stored on the disk. For example, I want to save file. The file Microsoft, for example, Word, Microsoft Word, call for example, whatever file name. Then the extension will be docx. So who told this computers made this one? Who told the file when I create a file? The operating system, So this is kind of we need the operating system. So when you need to access suspect computers or suspect to computer to acquire or inspect the data, we should familiar. We don't need this kind of operating system unless this is showing something. So we have something called CMOS. What the CMOS? Computers, complementary metal oxide semiconductors. CMOS it is, or sometimes called BIS, which is basic input output systems, or sometimes called AFI, which is the extendable firmware interface. So in those three version of the piece of hardware exist in something called motherboard. Um, if you go to the Google, Google here, motherboard. So, sorry, motherboard in the image. So this is the motherboard. This is the this is the piece of hardware we have in our computers inside, okay? So here the CPU, we should be placed here the CPU. This part of hardware or this one, or sometimes two, we call CMOS, this name, that we explain. This hardware, it is, you're gonna see the second, there is another small thing here. We don't care. But this is you're gonna find this is the most part hardware. So this is the big one, the CPU, the processor. The second one, this one. And this is the battery, by the way. So when computer press the power in the computers, there is something called post, processor called post, POST, which is stand for power on self test. Power and self test. What mean power and self test? Meaning computer, they want to check all hardware, it exists and work fine. So then, second, you're gonna search where the operating system could be Mac, it could be Windows, it could be Linux, whatever. So then, whatever operating system they found, they're gonna collect all files that required to boot these operating systems. This steps, post, and this stuff saved in this hardware, piece of hardware. We don't have control, just coming with the company build the computers, and we have this one. So all those names uh, to why they have names. All computers we can see most in 80s, 70s, then 90s we call BIOS. We upgrade this one. We made more. Then we have AFI later. So bootstrap process that we explained to you. that's make the computers doing this one. This is the software. For example, this is like a BIOS, or CMOS. All of them the same. For example, I want to adjust the system time. I want to adjust the system date. I want to, for example, this. Sometimes I have multiple hardware. I want to go booting from this hardware first or hard drive. So also in the um, easy way, understanding the disk drive. And the disk drive, we have a multiple DVDs. The DVDs, multiple DVDs. So we have a mini DVDs. I don't know, like see, like this one. See those DVDs. Kind of DVDs. Okay. Then each of those, see the small things here, all those, we call track, and this is this part together. So include track, this ones we call cylinder. So when I have a file, the file could be fit here. Then I have another file come here. What if I have a file? It come here, but this not enough. So we're gonna use the other, maybe another spot to add the file. So we need to link this one with this one. So this is the things of the um, cylinder and tracks. What the head and the head? See this head. So we have how when I read the data, this is like a head. It has like this, and have a sensor here. It have a sensor to read zeros or one. Volt, no volt, or have a volt. 7 volt. So we have a multiple head every DVD. So there's multiple head. Everyone has a head here. The next one have a next head there, etc. So this head to move around, it's gonna move around DVD to read the data. When you have a data, Okay. See in this now, the multiple head. We have a DVDs here. We have this is for example, have a 36 or 63 sectors. We have a track. We have those. So we have a disc platters. We have a lot of discs here, or DVDs, whatever, and stuff like that. It's not DVDs, the same DVD. It's more sensitive. It's more, but it's same technique. It's same technique. So we have a zoom bit record. I have a track density bit recording, or ZBR, which is a method that using by disk to optimize tracks. So, where's the best place to put the data? Where's the best put the data? Density, how much data I can put in the track. For example, 1 byte, 1 giga, 1 mega, 100 mega, 25. So this will be the amount of the data and this can hold. Area density also meaning how much amount of data we can put it in the disk itself. Flash memory, which is USB drive, it's another way to saving now. There is some computers coming with some hardware to saving the data as a flash memory as well. So we call solid state storage device. Storage device. We have Microsoft file structure. I don't want to go too much detail here. So cluster range from 512 bytes. So when you're creating the DVD, when creating the disk, we have a disk here. We have a command called format. So we have a disk here. We have a track, like this cylinders. Actually, let me change the color if I have different colors. So and we have a track. This is the cylinder, then track. Then we decide whenever I have a data, I gonna group the data. This group together, two tracks together. So this is what we call cluster. Cluster could be 512, could be 32,005. So clusters technique of storing the device. Technique of storing the device. And every file we have a logical address and physical address. What mean logical address? Logical address meaning the address. For example, if I have a memory here, let me change the color one more time. So if I have a memory here, computer memory, and this is hardware. This is hardware. Who build the memory? The company, like a Dell, whatever company. So for example, this address called 10, this 20, this 30. So when I have a data here, I ask the hardware to tell me this data, for example, X exists in the address 10 in the memory. But however, the operating system, when the operating system coming, he has also a way to addressing the data. For example, this is 70. This is maybe A70. This is B80. This is C90. So operating system, when you ask operating system, where's the X file? Say in 870, you know. This is we call logical address. This we call physical address. Physical address, the address that created by company, create the computers. The address by created by operating system called logical address. Partition gap. What the partitions? So partitions, um, when I have the data in the disk here, so we have, for example, I put the data here. I put some data here. Next data, I will not put it here. I put it here. Why? We keep some gaps. Why? To be like a boundary. To be like a boundary between those systems. You know, master boot record, which is the where's the partition table, meaning this is the first place when you turn the computers, we call address 0 or sector 0 or the place 0. So operating system, you go to this place to see what operating system you have and what the file for operating systems. So this is like I show you some binary hexadecimal stuff. We don't care about the disk partitions. We'll not go this level, even the IT with our team. The file allocation table called FAT. The system, and you just want to do something here, very simple. For example, I explained that before, and I discussed this before actually. When we have a file in the Microsoft, we're not able to open it in the Mac. When we have a file in the Mac, we're not able to open it in the Microsoft. Why? Because the file system. So the file system we call file allocation table, called FAT, F-A-T. This exists for. We need to know just to know the term. We need to know, that file system for Microsoft. And Microsoft, it's in 1990, have a called FAT16, then we have a FAT32, then have a EX FAT. So this is the different names, different technology, because computer speed up, you know, storage up, stuff like that, you know. And also, we have these commands. I don't care about them. Don't care. We cannot apply those. It's if you run those commands, it's gonna be will be affect the computer. So drive lags and the file lags and stuff like that. So here, just to tell you, this is the space. When you found it, we call EOF. EOF stands for end of the file. So I have a file here, and we leave this lags like a 120 bytes. So to make this files end, you know. Again, we have some softwares. Tell me how many clusters we need. We don't need that even in our computer front Zax actually. Deleting file. The file, when delete the file, Microsoft not delete the file, delete the name. For example, if I have a file, I create a file, and this file, this is the hard drive. So I have a table called FAT, F-A-T. So this FAT, for example, I have this location, number 1, number 2, number 3, number 4, number 5, number 6. It's simple, you know, simple scenario. So I create a file called my a.doc. So this is the file name, a.doc. Then this one file name and this location or the address. This address and location number 6. So whenever we open the file, the user requests the operating system open the A file, the operating system go to the file tab of FAT table or file location table to read the file. Here the file, the user need to open a.doc. From this table, they tell okay, go to location 6. They go to the address 6 to open the file from here. Okay. Now, what if the user want to delete the file? So we delete the file, just we're gonna delete it from here. So location 6 will have a nothing front, meaning it's available. But the file exists. The file will be exist till we overwrite it. Till we overwrite it. No one, the business system will not go to delete the data. Data will be exist. But the only things will be used we call unlocated. Unlocated meaning the data will not the name we deleted. Then Microsoft come with the NT file system, new technology file system. It starts with Windows NT, which is Windows Server, then later apply on all Kubernetes system. We have another things called NTFS. NTFS using Unicode. Unicode meaning not ASCII. Unicode, international data format. International data format. I don't want to go to the deep in this one. And this is the table to show you NTFS systems. So NTFS systems, also we have something called MFT, which is metadata. The metadata is information about the files, such as like a volume, a log file, stuff like that. Attribute, etc. Bad cluster, bad sector, stuff like that. So every file information has attribute ID, and this ID meaning it has some values. Again, this is some other informations. We don't care about it. This is too much deep. Just if someone need to investigate more details. But this is, by the way, these numbers, hexadecimal numbers. This number, hexadecimal numbers, okay? And also this show you how we can read the data. Actually, in the computer forensics, we don't know go deep, but this is for knowledge in advanced encryption or stuff like that. Someone have a high level of the detections. Um, this is everything's about the Microsoft here. I'm gonna stop at this point and thank you so much. And this is what I need from you to know about these things, the file types and some these terms. Okay. Thank you. See you next video. Thank you.